Okay, yeah, good evening, sir. At last, whew, yeah. Okay, without wasting any more time. Um, okay, these libraries are imported such that I can be able to print to the console and maybe get input and output from the user. Then the standard lib that helps me with being able to allocate memory, Then from there I go to the definition of struct node. To avoid typing struct node every now and then, I use type def, and for that reason, yeah. Then maybe something I need to confirm here. This part, struct node, the reason as to why I use struct node here is because for this part at this point the compiler doesn't really know what what node is at this point, because it's within the definition, so it really doesn't know. That's why inside here I use struct node, but then elsewhere, like here, I just use node. I don't need to say struct node. Okay, so here this function creates the node. I first ask the compiler to allocate memory where I'm going to store my node. From there, this is a pointer variable which does that. It allocates memory and stores it in this pointer variable, which stores a memory address. In that memory address, from there I will be able to overwrite the data stored in that memory address, the number. I'll be able to edit it with the value that any user will input here. From here it will point to null because it's a node in a random location in memory. Then the result will be returned, which is the address of the node where it has been created. From there I created a function which enables me to print the list. This function right here, it first initializes a pointer. This function right here initializes a pointer, a temporary pointer, which points to the head, which points to the value that's stored in the head. From there it loops through using this while loop as it prints the values within the list. Yeah, so basically the values in our list are integers, and then this arrow helps me to access the value stored in a certain memory address, that arrow thing. Yep. So we go to appending. We want to be able to add a value at the end of our node. So if the address of the head is equal to null, if the head isn't pointing anywhere, that means it's equal to null. Then that means there is no list, so we just have to equate our head to the address of the new node, such that our head points to the new node, and that's our new list. Otherwise, we create another pointer variable called current, which can be used to loop through the whole list. And while the value, that's the dot next in that memory address, is not equal to null, that means we haven't yet reached to the end of our list, so we should just update the value. We should just update the value of our node, the value stored in our node. That's struct next. From here we say current next is equal to new node. That means the value stored in the last node. Remember, our last node points to null, so we're just updating where it points to, such that the address that it's storing is the address of our new node. That way we shall have created the list. We shall have appended to the list. For prepending is all about making the head point to our new node. So we create our new node based on the value that the user will input here. Then the new node points the address of the new node new node dot next will then point to the, this simply means here with prepending we are trying to add the value, of our, we are trying to add the value that we want at the beginning of the list. So when we say new node to next, we are making the dot next in our new node point to the first element in the list, and then we shall use this to make the head point to our new node. So that way we shall have prepended to the list, since our new node is pointing to the previously first element, and then the head is pointing to our new node. Yes, so we come to delete key. We come to the delete key. So deleting, basically what we are trying to do is we are trying to make the node that was previously, the node before the node that we want to delete, we want it to point to the node that the node we want to delete was pointing to. So for that reason, I set this condition here just in case our head is equal to null. That means the list is empty, there is nothing to delete. Then from here I said we are going to use this temporary what is it called, we're going to use this temporary pointer address to loop through the list. That's why we initialize it to start at head. Then we shall need a variable to store our previous the address of the previous node. So for here we say if the key is equal to 1, that means if a user wants to delete the first element, what we do, we just make our head point to the value, point to the address, to the next address that node was pointing to. So that way we shall have just eliminated our node, that node that we want to delete out of the list. And then it's always good practice to free memory in C programming such that we can avoid memory leaks. Then at this point we can exit this function by using the return button. Okay, from here, so this was in case the user wants to delete the first item, but in case the item is not the first, we shall have to create a counter which we can be able to, here we are deleting by key. I forgot to explain, key is like a position. Key is like the position in the list. So if we use this to count the position that we are in the list, and if for as long as this I is less than the position which we want to delete, then that means we haven't yet reached. For as long as it's less than this, for as long as I is less than this, and at the same time the temporary is not equal to null, we should just execute this and then increment I by 1, for which here we make the temporary node become the previous, and then we increment this such that it can bring in the next node into this loop. Yes. Then in case, let's say all these, let's assume that here the temporary variable is equal to null before reaching the position that the user wants to delete at. We can be able to check that from here, and here we can just say key not found, because the temporary is equal to null. That means we have reached the end of our list, but we haven't yet gotten the key that the user wants. So that simply means the user input an invalid key, and then here we can exit the function. Other than that, if all these conditions have been tested and they are right, then that simply means that we can now delete the value at that node by just making the previous node, the dot next of the previous node, point to the dot next of the node that we are going to delete. So that way we shall just be ignoring the data in that node. We shall just be using its value, and then we free the temporary variable as usual to avoid memory leaks. So, deleting by value. deleting by value is like when we want to look through our list and then look for a value that we want to delete. Let's assume we have a list of 1, 2, 3, 4, but then we want to delete it. What we do, we just create. There's so much noise here. Okay. What we do is we just initialize. What we do is we just use this if statement. Sorry, too many distractions here. What we do, we just create an if statement. In case the address of the head is pointing to nothing, which is null, then that means the list is empty and there's nothing to be deleted. Otherwise, we create a temporary pointer of type node, which can enable us to loop through the list. Then we also create a previous pointer variable, which enables us to store the address of the previous pointer variable. So this was something I had implemented. This here. I was saying if the temporary variable is not equal to null and temporary is equal to the value, and the temporary node, its number is equal to the value we are looking for, then that simply means we just make our head point to the next variable, and then we free that. But I realize that the while loop can also do this, so this was just trial and error. But yeah, from here what we can do, we can now create this while loop that says while the temporary node that we are working in right now its value is not equal to null, its dot next is not equal to null, and also temporary its number is not equal to the value, we should just make the current temporary value our previous, and then we make the next temporary value, then we make the next value it's pointing to our temporary value. Otherwise we should just do this. Otherwise, if the temporary value is equal to null, that means there is nothing to be deleted, so we just print value not found. If all these conditions have been tested and they are right, what we do, we just make our previous node, we make its dot next point to the next address which the node that we want to delete was pointing to. Such in that way we shall just be ignoring that node, so we shall have deleted it. And yeah, it's always good practice to free memory. This is too much. My throat is starting to hurt. Okay. Yeah. So inserting by key and inserting by value. Yeah, inserting by key. Here what we want to do, we want to be able to insert a value at a certain position, and inserting by value, we want to be able to insert after a certain position. So that's how I understood it, and the implementation is in my code. So for here, if I want to, this is star head is equal to head if head is equal to null or the key is equal to 1, then this simply means we just have to prepend the value. That's the same as prepending. We just prepend the value at the start of the list. Otherwise, if star head prepend head value, yeah, that's it. I thought I had seen an error. Okay, so here we shall create, otherwise we shall have to create a new node, and then we use a temporary variable, temporary pointer variable, to loop through and find that position where the user wants us to put that value, and then we shall have to add it there. So here I used I as my counter, and then this is the condition. Which is if the temporary variable is not equal to null and I is less than the key, -1, then that simply means we haven't yet reached the value where we want to add this. So what happens here, we just make the temporary variable point. We just make our new temporary variable. We just make our temporary variable point to the next thing it was pointing to. Where are we? Okay, we just make our temporary variable point to, we just make the node that we have been working with. No, sorry, we just go to the next node. Yeah, that's the right word. Sorry for going in circles, but yeah, we just basically go to the next node using this. Otherwise, if the temporary is equal to null, and this simply means the list is empty, and this value and that this key can't be within an empty list, so obviously key not found. That's what we print. Otherwise, that means all these conditions are true, and just to insert at that point where this loop breaks, that means obviously this is not false. So what we do, we just make our new node point to the next. We just make the value of our new node point where the previous node was pointing, and then we make that previous node, which is now previous, because since we have added our new node, that node that was previous, obviously we now have to make it point to our new node. So that way we shall have inserted a node to the list. If you want to insert by value, it's slightly similar. Obviously, if you want to insert by value, then that means if the list is empty, we shall not be able to do what? To insert by value, because the list is empty. So here, this message will be printed, list is empty. So then the node, we create our node using this star temporary. We create a temporary variable of type node or struct node if you didn't use type def. Of type node, we equate it to the head such that we can be able to loop through, and while temporary is not equal to null and the value stored at that node is not equal to the value we are searching for, that means we haven't yet reached, and our temporary node should be updated to the next node. Yeah, at least I feel like that's the best explanation I've made. Yeah, wait till those are the right words. Our temporary node becomes the value of the next node that it's pointing to. And for as long as that temporary is not equal to null, if that temporary is equal to null, that simply means we have reached to the end of our list and the value hasn't been found. Otherwise we make the new node. Otherwise, that means all these conditions are true. So to insert at this point where all these conditions have been met, we just have to make our new node point to the next node we just have to make our new node point to the next node that the temporary node was pointing to. That was the node that was in that position in the list. Then we make that node point to our new node. That way we shall have inserted it in that position. Okay, so from here I created a sample list using simple numbers. Using simple numbers, I created the head, which can be able to point to the first item in the list, and then I created variables that store the choice, which will be made here. The choices that will be made, I created a variable for them, and also a point that will store a variable that will store the data, which is an integer, down here in our while loop, which was in your question, sir. So from here what happens is we create this list, then I make the dot next. The dot next is this. I made the dot next. Here obviously the head must be able to point to the first node, but then I made the dot next of one list to point to the next list. For example, here the first node will point to node 2, the second node will point to node 3, the third node will point to node 4, fourth node will point to node 5. Yeah. So this is just a sample list for us to be able to test these functions, but other than that, yeah. So from here I used a switch statement. So a switch statement has cases 1, cases 2, cases 3, 4, 5, 6. In case the cases, basically what happens is it takes in the choice. So if case 1 is right, which in case the user puts a 1 here, it will print the list. If the user puts a 2, it will be able to execute case 2. If the user inputs a 3, it will be able to prepend. As you see, it will be able to prepend. If the user inputs case 4, it will be able to insert. If the user insert, we have two types. There is inserting by key, inserting after a key, and also inserting after a value. Inserting by key and inserting by value. Yeah, that's what I used. Then also we have deleting. Deleting also is case 5, but I also used a switch statement within this, whereby we were working where I also asked the users if they want to be able to delete by key or delete by value. Yeah, some of these functions you hadn't asked for them, sir, but I just included them just to understand what's going on, just to understand how to implement them. Yeah, that's what I did. And also case 6, which is exiting, I realized I can easily do this with return 0. Other than that, I tell the user that's an invalid choice, and I ask them to please try again. So let us execute. Let's test this code. Jesus Christ, I hope this video isn't going to be so long, but yeah, it's worth it in the end. I made some changes. Let me first compile, then I can do the list.k. So printing the list, this will print 1, 2, 3, 4, 5. Let me make this a bit bigger. Yeah, prints 1, 2, 3, 4, 5. So appending to the list, that's 2. And it asks me to enter the data I want to append. Let's assume I want to append 89. Appending 89 comes to the end. Assuming I want to prepend, that's 3. Prepending obviously asks me which data I want to prepend. That is let's say 67. I can add the data to the start of the list. That's prepending, which is 67. If I want to insert, yes, insert, it will ask me, do I want to insert by value or insert by key? Let's say I want to insert by value. Enter the value to insert after. Let's assume I want to insert after 2. The data I want to insert, 100. After 2, 100 comes into place. If I want to insert, let's say inserting by key. Oops, sorry. Let me just do this. So inserting by key, we want to insert, which is 4, by key. And they ask me to enter the key that I want to insert. Obviously, let's make this 2. Enter data to insert, 78. And there, 78 becomes our second item in the list. If I want to, let's go to delete. Delete is 5. Delete by value or delete by key. Let's say we want to delete by value. Which value looks weird here? Okay, let's delete 100. I want to delete 100. There we go. 100 isn't part of our list now. I want to delete. Let's try deleting by key now, which is 5. Delete by key, which is 2. Enter the key to delete. Let's delete. Which value looks weird as well? Let's delete the second item, 78. Doesn't really look good there. We shall have deleted 78 out of our position. So we want to exit this, that is 6. Takes us back to the compiler. Yep. Okay, that is it. Thank you so much. So